Good morning, everyone. So, welcome to my YouTube channel, Masaf. So, today we are going to see eighth lecture on infinite series. Today, we'll see uh, what type of series are called absolutely convergent series. Okay, let this is the let this be a series. Be a series. Then we say that this series this series converges absolutely if or converges absolutely or this series AN is absolutely convergent if this series taking absolute value of a terms of taking the absolute value of terms, this series is convergent series. Okay. So what is the definition of absolutely convergent? The series summation n goes to 1 to infinity. An is convergent if this series corresponding series of absolute value absolute terms of series is convergent. Okay. For example, you take this one summation n goes to 1 to infinity minus 1 to the power n plus 1 upon, into 1 into 1 upon n square. Okay. So what is an here? An is this. So what is this? This is 1 upon n square. Now this series, this series is convergent. We know this series is convergent. Therefore, therefore, this series is absolutely convergent. Now, second example, this series summation n goes to 1 to infinity sine n upon n square. Okay. Now What is an? An is equal to this sine n upon n square. So this implies an is equal to, okay. Now, now an term is this one, that is sine n upon n square, but that is less than 1 upon n square. Let's say this is bn. Let's say this is bn. Okay, this is bn. Now, this series and this series are no are series with non-negative terms. Non-negative terms, and an is less than bn for all n belongs to n. Okay. Okay. And what is this series? Also, this series summation n goes to infinity bn, that is summation n goes to 1 to infinity 1 upon n square, is convergent by comparison test. Part first, we get that this series is convergent by comparison test. So this implies this series is absolutely convergent. Okay. Now prove the result theorem. Every absolute every absolutely every absolutely convergent series is convergent. It means it means if if this series if an this series is convergent, then this series is convergent. Convergent. So let's see its proof. But converge is not true. Converge is not true. Not true. It means It means if this series an is convergent, then this series need not to be convergent. Let's see its proof. We are going to prove it. We have if a series is absolutely convergent, then the series is convergent. But converge is not true. It means there can be a series which is convergent, but its absolute value series is not convergent. Okay. So proof. Let this series is absolutely let this series be absolutely convergent series. It means it means this is convergent. Okay. Now now put Bn is equal to An plus An. Okay. Then this is always non-negative for all n belongs to. And we see that Bn is equal to An plus An, that is less than An plus An, that is equal to 2An. Okay. Now what we have? We have this one. Bn is less than 2 times An for all n belongs to n. And and this series summation n goes to 1 to infinity 2 times An is nothing but 2 times n. So this series is convergent because this series is convergent. Okay. Now by by comparison, test part 1, we get we get this series is convergent. This series is convergent. Now we know that sum of two convergent series is convergent and difference of two convergent series is convergent. Next, how we can write this term? This term can be written as so this implies So this implies summation. So what is this? This is Bn minus A1. So what is An is equal to? So what is it is this? Okay. So this will be cancelled out. It will be D. So this is, so how we can write this? So this is convergent series. This is, so this is convergent series. This is convergent series. And this is also, this is convergent series. And difference of two convergent series is convergent. So this implies An is okay, convergent. Hence, every hence hence every absolutely convergent series is convergent. Okay. Converse, converse is not true. Not true. You take this series. Now take this series summation and goes to 1 to infinity minus 1 to the power n plus 1 upon n. So this is log 2. So this is nothing but log 2. What is the, so this series we have, what is the partial sum of this series? What is Sm? Sm is equal to summation n goes to 1 to m minus 1 to the power n plus 1 upon n. Okay. Now this stands to log 2 as m tending to infinity. So this implies limit m tending to infinity as this. So this implies this series is convergent. So this implies this series minus 1 to the power n plus 1 is convergent. Now, what is absolute value of this series? Uh, times absolute value. So what will be this series? But this is divergent series because in auxiliary series, if value of p is less than equal to p, you can take p is equal to 1. This is divergent series. So we have Now we have this series minus is convergent, but this series summation n goes to 1 to infinity is not convergent. Not convergent. It means divergent. So this implies converge is not true. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next.